Hello boys, let's start a new chapter. It's called matrices. Now what is a matrix or a matrice? It's basically a rectangular arrangement of numbers. So it is usually written in the, not usually, it is written in the inside brackets. So for example, 2, 3, 0, 7. Whatever is written in horizontal form is known as a row. So this matrix that I have written has two rows. This is row 1 and this is row 2. And whatever is written vertically is known as column. Like the way you would have it in any other form, we've been using this term forever. There are two rows and in this case there are two columns, right? So this is basically a matrix. Now the next question is, why is it important? So the way I remember it is, the row is horizontal and column is vertical. I remember it with CV, right? So you prepare your CV to go for an interview. So CV is what I remember. So if column is vertical, then row is obviously horizontal. Perfect. Now, why do we need to learn about matrices, a matrix? Because this helps in a representation of data in a short, concise way. If you've ever seen Microsoft Excel, it is nothing but it works on the concept of matrix. So we'll get into details slightly later. I'll give you specific examples where it can be used. But for now, first thing I told you was row is horizontal and column is vertical. So in this case, there are two rows and two columns. Next comes order of a matrix. Now, order of a matrix is very important because it defines what can we do in terms of addition, subtraction, multiplication. So how does it work? Now, order is written in the form RC, which is the first term is the row, second term is the column. So in this example that we had, 2037, how many rows do we have? 2. Multiplied with how many columns do we have? 2. So this is a 2 by 2 matrix. Let's look at another matrix, 0, 3, 7, 1, 5, 11. How many rows does it have? 1 and 2. 2 multiplied with how many columns? 1, 2 and 3. So this is a 2 by 3 matrix. The order is usually written at the end as a subscript. You can call it, it's written at the end, or it can be written given in the question as well. What are elements? All these numbers inside a matrix are known as its elements. So these are 4 elements in this matrix. What is a row matrix? Well, a row matrix is basically a matrix which has only one row. So for example, 3, 5. This is a row matrix because it only has a one row. So this is one row multiplied with 2 columns. So it has one row. 3, 5, 11, 19. This is a 1 into 4 matrix. It has one row. What is a column matrix? Well, if you figured out what is a row matrix, you can figure out what is a column matrix. It has only one column. So 1, 3, 7. This has 3 rows into one column. So the column is only 1. What's a square matrix? A square matrix is basically a 2 by 2 matrix, or a 3 by 3 matrix, 1 by 1 matrix, or a 4 by 4 matrix, or so on and so forth, where the number of rows is equal to number of columns. So number of rows is equal to number of columns. In your syllabus, we will focus only on 2 by 2, 3 by 3 and 4 by 4, and the others are not in your syllabus. 1 by 1, yes, but the maximum that we'll go up to will be 2 by 2. 3 by 3 or 3 by 2 is not in your syllabus. Let's look at a rectangular matrix. Well, as the name suggests, it is in the form of a rectangle, right? So this is in the form of a rectangle, 2 rows and 3 columns, right? So this is a rectangular matrix. What is a zero or a null matrix? Well, when all elements are 0, all elements are 0. For example, this is a null matrix or a zero matrix. This is a zero matrix. this is a 0 matrix, right? So these are all elements are 0. A diagonal matrix. So diagonal matrix is a matrix in which the prime diagonal or the principal diagonal. This is the prime diagonal starting from the top left going to the bottom right. This is known as the primary or the main or the leading or the principal diagonal. Elements are there only in this element or only in the diagonal. Everything else is 0. So let's look at a 3 by 3 such matrix. 3, 5, 9. All other elements are 0. Right, so this can obviously happen only in a square matrix, right? This can happen only in a square matrix where it's only the diagonal which is going up from the top left to the bottom right. Let's move on and let's look at this other part. So what is a unit matrix or an identity matrix, or also known as I? In this this is a type of diagonal matrix. So this is a type of diagonal matrix where all elements in the diagonal are 1. Diagonal matrix, all elements are 1, and all diagonal elements are 1 and everything else is 0. So again, this is basically a square matrix. The primary diagonal, all elements are 1, everything else is 0. This order of this is 2 by 2. Let's look at this. This is a 3 by 3 diagonal matrix, which is a identity matrix or a unit matrix. Now, what's a transpose of a matrix? So for example, let's take this example. A is equal to 2, 0, 3, 4, 1, 7. This is the matrix A. The order of this matrix is 2 rows multiplied with 3 columns. Now transpose is written as A with the power T, or yeah, this is how it's written. It's not the power, but the T is written on the top of it. Is when you convert matrix row into column and column into row. So row becomes the column and the column becomes the row. So then this matrix will be written as 2, 3, 1, 0, 4, 7. 2, 3, 1. The first row became the first column, the second row became the second column. So now this becomes a 3 by 2 matrix. This is known as a transpose of a matrix. Transpose is not in your syllabus this year, so we don't need to worry too much about this, but I just wanted to share with you the concept, which is the row becomes the column and the column becomes the row. What are equal matrices? Equal matrices, as the name suggests, are matrices where all elements are exactly the same. So for example, 2, 1, 3, 5, and this is equal to 2, 1, 3, 5. Let this be matrix A and this is matrix B. They are equal only if all elements are equal, exactly equal, and are in the same position. Now, additive identity. If you remember your algebra from grade 6 or grade 7, you would know additive number is a number which when added to a given number does not change the number, which means 3 plus 0 is 3, which means this is the additive identity. So 0 is always the additive identity for a number. Similarly, for a matrix, a null matrix is always the additive identity, but null matrix of the same order. Null matrix of the same order. For example, 2, 1, 3, 5 plus 0, 0, 0, 0 will always give me 2, 1, 3, 5. Right? This is basically it. This is the additive identity. And what is additive inverse? Well, again, if you remember algebra from grade 6 and grade 7, you would know that the additive inverse of 3 is negative 3. So additive inverse added to a number will always give 0. So this is the additive inverse. Right? Additive inverse. So in this case of a matrix, opposite matrix, which means exactly the same numbers but the opposite sign. So for example, if I have a matrix which is 2, 1, 3, 5 and I add another matrix, so let this matrix be negative 2, negative 3, negative 1, negative 5, this will give me a matrix which will be 0, 0, 0, 0. Perfect. So additive inverse is a matrix which when added to a given matrix gives the value of a 0. In this case, 0 is a null matrix of the same order. And how do you add or subtract? I hope looking at these two examples that I did, you would have realized how to add or subtract. You add exactly the same element with the same element. So if I am adding 2, I will add it to the first row, first number. So if I were to add 2, 3, 1, 5 with -2, -3, -1, -5, I will add first element with the first element here. So 2 minus 2, this becomes my first element. 1 with -1, 1 minus 1, 3 with -3, and 5 with -5. So 2 minus 2 is 0, 1 minus 1 is 0, 3 minus 3 is 0, 5 minus 5 is 0. So that's how you add and subtract. That's basically it. Basically what it means is our first exercise is nothing but adding and subtracting. Life will become very simple. Let's look at some questions. It'll make your concept even clearer. So let's look at the first question. So I am on exercise 9a, question number 2. It says, given x 3 y plus 2 z minus 1 is equal to 3 3 1 2, find x, y and z. So let's compare. We know since these are equal, which means this element is exactly equal to this, which is simple. So x is equal to 3. So I have figured out x is equal to 3. Now y plus 2 will be equal to 1. So y plus 2 is equal to 1, which means y is equal to -1. This is also done. Let's look at this one. The 3 and 3 are equal, already given. Now this is z minus 1 and 2. So z minus 1 is equal to 2, which means z is equal to 3. Perfect. So I have to ideally highlight my answers so that it is easier for the question checker to correct it properly. If you want, you can also write your answer in the set form at the end. This is 3, -1 and 3. Perfect. Simple basic addition and subtraction. All you need to ensure is you are adding the correct element. Row 1, column 1, add it with row 1, column 1. Row 2, column 1, add it with row 2, column 1. Exactly the same thing. Let's look at question number 3, part 2. It says a, b plus c, a minus b, these are equal. We need to solve for a, b and c. So a is given equal to 3. This one is simple. A is equal to 3. Done. Next is a minus b is equal to -1. So a minus b is equal to -1. We know a is equal to 3. So 3 minus b is equal to -1, which means 3 plus 1 is equal to b, which means b is equal to 4. Done. And let's look at the c. So b plus c is equal to 2. So b plus c is equal to 2, which means 4 plus c is equal to 2, which means c is equal to -2. Done. Ideally, I should highlight my answer so that it's easier for the question checker to correct it. You can also write your answer in the set form at the end. ABC is 3, 4 and -2. Did I do it correct? 4 plus 2 is 4 plus c is 2. So c is equal to 2 minus 2. Yeah, that's fine. -2. Perfect. Let's look at question number 5. Question 5 says a, b and c are given. I need to calculate a plus b minus c. This one. So I notice that this is 2 rows into 1, 2 rows into 1, 2 rows into 1. So you can add only if the order is exactly the same, like I had said earlier. Similarly, you can subtract only if the order is the same. So let's add and subtract. So this will be a plus b, which is 2 plus 1 minus 6 because c is being subtracted, and this will be 5 plus 4 minus of -2. Please note we are subtracting -2, which means we are adding. So this is 3 minus 6, which becomes 3 minus 6 becomes -3, and 5 plus 4, 9 plus 2 becomes 11. So -3 with 11. Let's look at question number 5, part 4. So it's a minus b plus c. So I have a, which is 2, minus b is 1, plus c is 6. 5 minus b is 4, and plus c is minus 2 because value of c row 2 column 1 is -2. So this will be 2 minus 1, 1, 1 plus 6, 7, and 5 minus 4, that's negative. 5 minus 4 is 1, 1 minus 2 is negative 1. So that the answer is 7, negative 1. Please note that you can add or subtract only if the order is exactly the same. Chalo, let's move on to the next question. The next question that we do will be question number 6, part 2. So let's look at this question. Wherever possible, write each of the following as a single matrix. So they have a 2 by 3 matrix which is being and then another 2 by 3 matrix we need to subtract. So I will look at the first one, 1 1 and 1 1. So 2 minus 0, this is 5 minus 6, 3 minus 2, 6 minus minus 1, 4 minus 3, and 7 minus 0. So this is 2, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 6 is negative 1, 6 minus minus 1 is 7, and 7 minus 0 is 7. So that's my final answer. So this is the, on subtracting it, this is what we will get. Let's look at question number 6, part 3. So this matrix is a 2 rows and 3 columns. So 2 by 3 matrix, and this matrix is a square matrix which is 2 by 2. Is the order equal? No. So can this be added or subtracted? No. So you will write your answer as, since the order of the two matrices, matrix is singular, matrices is plural, of the two matrices is different, therefore they can't be added. Done. Let's look at question number 8. It says given M is the name of a matrix which is 5, negative 3, negative 2 and negative 4. Find the transpose matrix MT. So this is note, like I said, is not in your syllabus, but what transpose means, convert a row into column and column into row. So this is, let's look at the first row. So the first row becomes the first column and the second row becomes the second column. So this is it. I am not adding or subtracting. This is not in your syllabus for this year, but I still wanted to understand what transpose means. So let's move on to the next one. The next one that we do is question number 10, part 2. It says A is given as 2, negative 3, B is 0, 2, C is negative 1, 4. Find matrix X. So we need to find the matrix X for both examples. So we are doing part 2, which is A minus X is equal to B plus C. So I need to find X. So this can be written as, so I have to find X. So let me put X on one side. So it will become A minus B minus C. I take both of these on the other side. This becomes equal to X. Let's check it again if I'm doing it correct. So this is A minus B minus A minus X is equal to B plus C. So it will be A minus B minus C is equal to X. Perfect. This is fine. So X will be equal to A, which is 2, minus B, which is minus 0, minus C, which is minus of negative 1. This is my first row, first element. Right? The next one is 0. This is negative 3, minus 2, minus 4. Right? So this is a 1 into 2 matrix, 1 into 2 matrix, 1 into 2 matrix. My answer obviously is 1 into 2 matrix. So 2 minus 0 plus 1, that's 2 plus 1, and this is negative 3 minus 6. This is 3 and negative 9. Perfect. So it is advisable that you take the X in one side so that you are able to add the matrices or subtract them properly. Let's look at the last question. Last question is question number 11, part 1. That's what we'll do. It says given A is another matrix, B is some matrix, find X in each of the following cases. So A plus X is equal to B, which means X will be equal to B minus A. So since I need to find X, I may take X on one side and let's subtract. So B will be 3 and I subtract the first element, which is negative of negative 1. Then is negative 2 minus A, which is negative 2. So I'm looking at this with this, this with this, 0 and negative 3. So negative 3 minus 0 and 0 minus negative 4. So this is 3 plus 1, which is 4, minus 2, which is negative 4, negative 3 minus 0, that's negative 3, and 0 plus 4, that's 4. So that's my answer. Therefore, X is equal to, in fact, in this question also, you should write X in the final answer and highlight it. Perfect. So X is equal to a matrix which is a 2 by 2 matrix. Writing order important? No, not important unless the question asks for it, but my habit of writing the order at the end. Perfect. Thank you so much. I'll see you in the next video with exercise 9B. Thank you. Bye-bye.